So this video is for Integrated 3, the PowerPoint for Semester 1 Final Exam Review. So, and we did it as a Pear Deck Google slide in my class. So let's get to the first problem here. So the very first problem, we wanted to write an equation for this graph. And this graph is an inverse function. So y is equal to a over x minus h plus k. Now, in this case, they did not say exact and they did not give us a point. So we can assume our a is 1. Okay, for this, so I'm going to write it as y is equal to 1 over x minus h plus k. And then I'm going to try to find my h and my k. So to find my h, I'm drawing it, I should have chosen a different color, this was already in blue, but I'm drawing this x equal 3. That is going to give me my h. So I am going to grab my eraser, get rid of this, and this is now going to be x minus, whoops, got to get my pen back again, x minus 3. Then I'm going to find my k. I'll do this one in red this time to use a different color. I'm going to go and draw my horizontal asymptote, which is at y equal -2. That is going to change my k. So my k here is now going to be -2, and then that's our equation. That's our equation. Now, just a little quick note as to if you had to find an a, you could always plug in a point. So this point right here is at 4, -1. You could plug that in for your x and y and find your a. How I personally do it is with these, basically the general equation for these is y equal a over x, where if I rewrote this, this is really x, y equal a. My x and y distance, okay, coordinates if I'm at 0, 0, but distance from my asymptote, basically, if I multiply those together, I get my a. So in this problem, if I come to where my asymptotes meet, because this graph's been shifted, so I'm kind of thinking of this as like my original x and y axis. Where am I physically? I went over 1, 1, and 1 times 1 is going to be my a, and that's what I do have. Okay, probably more information than you wanted to know. So let's go to the next problem. On the next one, we want to find the exact, sorry, I went over too many, the exact equation. So this time I definitely need to find my a. So for this, the first thing I'm going to be looking at is my asymptote, my vertical asymptote. So I'm going to draw this in pink. So this vertical asymptote right here, which is at y equal -1, this is going to tell me that my graph has been moved down 1. So I know I'm going to have a -1 at the end of my equation. Our point right here, this point right here at -2, 0, this is our locator point. It's telling us that we moved left 2, okay? And again, this over here is telling us we moved down 1. Everything got moved down 1 and left 2. Now I just need to figure out what my b is, what my multiplier is. So if I look at where my 1 above, when I say 1 above, I go to my asymptote and I look to say, hey, where are my 1 above? Here's my 1 above, okay? This is a height of 1. As I go to the right one, my height is now 2 above. As I go to the right again, mine is 1, 2, 3, 4 above. So let me just jot that down. I'll do that in blue, okay? So again, just understanding this, oops, helps if I can write. This distance here, that height is 1. This height is 2. This height is 4, okay? So what I'm doing every time is I'm timesing by 2. I'm doubling. So that is my multiplier. So then my equation is going to be y equal to, because I'm timesing by 2, I'm doubling every time. And then I moved it to the left 2, so x plus 2. And then I moved it down 1 minus 1. And that is our equation. Okay, so our next one. This, again, I want an exact equation. So I'm going to be worrying about my, my accuracy, okay? So on this one, I am going to be thinking of y equal a times the absolute value of x minus h plus k. And the point that I'm going to be looking at is this -3, 4. That's my h and my k. That's my vertex. So that's going to go in for this h and this k. So now when I write my equation so far, I'm going to have y is equal to a, absolute value of x plus 3 plus 4. Now to find your a, there's 2 ways you can find your a. One way is to use the point that they gave you, okay? And the point that they gave you is this point right here, which is at -1, 1. And you can put that in for your x and y, and I'll do that in a second. The way I think about it is this is linear in nature. We basically have 2 lines intersecting to form this absolute value, okay? So how are we moving? From my vertex to this point, I am going down 1, 2, 3 to the right 2. So that's like your slope. Down 3, right 2. Down 3, right 2. That's what I keep on doing. So that is going to become my A. So my equation is going to be, oops, let me grab my pen again. Y is equal to, and again, it's an upside down absolute value. So -3/2, absolute value of x plus 3 plus 4. If you don't feel comfortable with that, that's fine. You can come and take this equation that we got, and you're going to be putting in your -1, 1. So I will do that over here in pink. So I'm going to go 1 is equal to a absolute value of -1 plus 3 plus 4. Again, I'm just putting in my x and y in place, the -1, 1 in place of my x and y. So I'm going to get 1 is equal to, and here I'm going to get the absolute value of 2. Here, let me put my a. So this right here is going to be a 2. And the absolute value of 2 is 2. So I am going to write it as 2a plus 4. I'm going to be minusing 4 from both sides, so I get a -3. I'm going to be dividing by 2, so I get a -3/2, which is the same thing that we got over here, thinking of it as a slope. Okay, so you can do it either way, either way. I only think about my a as a slope when I'm either dealing obviously with a line, which would be my m, my slope, or with an absolute value. Do not do that with any other type of graph, okay? Okay, next problem. So this one is a cubic graph. So for this, it's going to be this y equal a times x minus h cubed plus k. Again, for this one, I want to look at my locator point or inflection point. That's going to be this point here at not -2, I'm at +2. +2 comma -1. That's going to be my h and k. So I'm going to put that in for my h and k. So I'm going to have y equal a times x minus 2 cubed minus 1. Now to find my a, couple ways you can do it. You can use that point, and I'll show that in a second, or if you go from your inflection point and you go out 1 cubed is 1, so I should be going up 1. If I'm not going up 1, that means my a is timesing and changing that height. In this case, I went over 1 cubed is 1, and I went up 1. So my a is going to be 1. It has not been adjusted. Okay, so this is going to be y equal just x minus 2 cubed minus 1. That's going to be my equation. Again, if you don't feel comfortable doing it that way, take the point that is given to us, 3 comma 0, and I'm going to be putting it in place of this for my x and y, and I'm going to have 0 is equal to a times 3 minus 2 cubed minus 1. So I get 0 is equal to, and when I'm doing this 3 minus 2, I get 1. 1 cubed is 1. So I'm going to get just basically a minus 1, and you see my a is 1. So I got that both ways. Okay, so next one, get my mouse. Another parabola, this one again exact. This is going to be general equation, y equal a times x minus h squared plus k. So we are looking at this vertex right here, which is at negative 5 comma 3. That is your h comma k. So I am going to have y equal a times x plus 5 squared plus 3. Okay, and now I need to find my a. 2 ways to find your a. Again, the way I always think about it is, what type of graph is this? This is an x squared graph. This is a parabola. So I'm going to be squaring 1 squared, 2 squared, 3 squared, 4 squared. Okay, I'm not concerned about physically what point I'm on the x and y axis. From my vertex, how far am I moving and how far am I moving up? So what I mean by that is the following. If I come to my vertex and I go out 1 squared is 1. I should have been right here at a height of 1. I wasn't. I was up at 2, 3. I was 3 above. That means my a is 3, because 1 squared is 1 and I times it by 3. Okay, so my a is 3. Okay, so this is going to be y equal 3 times x plus 5 squared plus 3. Again, if you don't feel comfortable with that, take the point that they gave us. Now I'm looking at the actual coordinates, because this is a point. I'm going to use the point. I'm at negative 4 comma 6. So I'm going to be plugging that into this equation for my x and y. So I'm going to get 6 is equal to a times negative 4 plus 5 squared plus 3. 6 is equal to, and here my negative 4 plus 5 is 1. 1 squared is 1. So this is just going to be a plus 3. I minus my 3 and I get my a is 3. So I got the same thing here as I did here, whichever way you feel comfortable doing it. Okay, next one. Another, write the equation. This one is a square root graph, okay? So this is going to have the general equation of y equal a times the square root of x minus h plus k. We're going to look at this locator point right here, this point right here, which is at negative 4, negative 2. This is going to be my h and k. So I am going to get y equal a times the square root of, and again, that negative 4 makes this an x plus 4, and then that minus 2 minus 2. Now, again, I'm going to go through this 2 ways. I think of this as square rooting, okay? So I come over here and I go, okay, well, as I go out 1, I'm going to take the square root of 1. As I go out 2, I take the square root of 2. Not nice. I like to go out nice squares. So as I go out 1, the square root of 1 is 1. Touches the graph. Okay, my a is 1. But let's just double check. I go out 1, 2, 3, 4, and the square root of 4 is 2. So my a is 1. I'm not changing it. Okay, I'm not having it go higher than it should be. So this is going to be just plain old y equal the square root of x plus 4 minus 2. Again, if you don't feel comfortable thinking of it that way, take the point, and this point is 0, 0, and come put it into this equation for your x and y, and I get 0 is equal to a times the square root of 0 plus 4 minus 2. So I get underneath the square root of 4, and the square root of 4 is 2, so I get 2a minus 2. I add my 2, I divide by 2, and I get my a is 1, which again is what I got over here. Okay, think of it either way, whichever way works for you. Okay, so next problem. Okay, so for this, this is getting back to integrated 1, okay, fraction besting. Okay, this is going to be important when we get to second semester, though, that we can do it with this because it's going to be more complicated second semester. So let me do the following. What I'm going to do is I want to get rid of a 4 and a 5. So I want to think of what is the smallest number I can multiply everything by that 4 would go into and 5 would go into. Kind of thinking of what is the least common, what is the lowest common denominator that you can have. So with a 4 and a 5, that's going to be 20. So I'm going to multiply by, here, let me not put an X there. I am going to multiply by 20, everything by 20, everything by 20 to get rid of that 4 and the 5. So let me just get rid of these for a sec. Okay, so I'm going to go 20, one more time, 20 times this, 20 times this, and 20 times this. Now, hopefully my 4 and my 5 will cancel out. So my 4 goes into this 5 times, so I'm going to get 5x. My 5 goes into this 24 times. So again, I multiply these together and get a negative 12. And over here on this side, I get a 40. Now I solve. So I am going to get 5x is equal to 52. And then I'm going to get x is equal to 52 over 5. And you can just leave it like that. Okay, so next problem. Write the exact equation of the path of a ball if it is thrown 40 feet and reaches a height of 8. Okay, so for this, I am going to draw this out. I'm going to just assume I'm starting at 0, 0, 0, 0. My parabola is coming to here, let's say, and it ends here at 40, 0. I know that the max height is 8. That means my vertex is going to be at a height of 8, and your vertex has to be halfway between your two x-intercepts. So if this is 0 and 40, halfway would be 20. So this point up here is going to be 20, 8. Okay, so this point up here is going to be 20, 8. So then I'm going to have my equation. Y is equal to a times x minus 20 squared plus 8, because that's my vertex. Now to find my a, I'm going to use one of the points, not my vertex. I would prefer to use 0, 0 than 40, 0. Okay. Close that up. So I am going to do 0 is equal to a times 0 minus 20 squared plus 8. So I get 0, here, I'm going to bring over the 8. So I'm going to get negative 8 is equal to, and negative 20 squared is, when I do 0 minus 20, I get negative 20. Negative 20 squared is 400. So I get 400a. So I'm going to get negative 8 over 400. And if you put this into your graphing calculator that you have on your Chromebook and you do alpha and the y equal, you're going to get a fraction option. And you could just put in negative 8 over 400 if you're having trouble reducing this. But this is going to end up being negative 1 over 50. So my equation, let me come over here, let me erase my a. And I'll put this in blue so you see what I'm doing. Whoops, helps if you can actually see what I'm doing. Let me get a pen. So -1/50. Okay, again, here, let me write that so my negative is not part of my fraction. And this is going to be my equation. Okay, next one. On this one, write the equation of an absolute value graph with a vertex at 0, sorry, at 0, wow, -2, 5, cannot read today, -2, 5. So this is going to be my H and K. Sorry, I'm writing with my finger if you're wondering why it's kind of a mess. So this is going to be the X and Y that I'm going to plug it into to find my A. So my general equation is going to be Y equal A, absolute value of X. Now minus H, so this is going to become a +2, and then plus K, so this is going to be a +5. And then I am going to be putting in this 3, -1. So I am going to get -1 is equal to A times 3 plus 2 plus 5. Down here. So -1 is equal to 5A plus 5, because absolute value of 3 plus 2, absolute value of 5 is 5. I'm going to subtract my 5, and getting -6, divide by my 5 and getting -6/5. So I am going to come back up here to my A. I am going to clean that up. And here, I'll do it in red. My A is -6/5, and that is my equation. Okay, next one. So for this one, translation. What translation is applied? So what we're going to be looking at is this down here is going to be moving it right 1, because whatever makes that 0 is going to be how I'm moving. So the X, what X makes it 0? An X of 1, so you're moving right 1 on your X. And then the 2, this +2 is going to be up 2. So my translation is going to be, we are translating every single point, including the asymptote. Every single bit of this graph is translating right 1 and up 2. Okay. Okay, next one. So on this one, let me move this so we can read it. So we are going to complete the square to put in graphing form. So seeing this, this is actually going to be a circle. And just to make sure we understand what in the world we should be trying to get, for a circle, we should be trying to get the following. X minus H squared plus Y minus K squared equals R squared. And R squared is just going to be a number. Okay, it's a number. Don't worry about squaring that. Whatever number you get there, that's your R squared. So what I like to do is I like to get my X's together and my Y's together. So I've got these X's, I've got these Y's. And this -3, I'm going to add and take it to the other side. So I am going to write the following. I'm going to go parenthesis x squared minus 6x. I'm going to leave a spot to complete that square, plus y squared plus, and don't forget the plus in between. There's a plus in between. 12y, I'm going to leave a spot, equals, and when I take the 3 over, it's a +3. And then I'm going to be actually adding in 2 things. Again, the 2 things I'll be adding is whatever I put here and whatever I put here. So in integrated 2, you guys did it kind of using an area model, doing a box, but basically what happens is you're going to take the number in front of your X, which is your B. You're going to, I'll write it over here, you're going to take half of that, which is -3, okay, because you're trying to split it into half, physically make it be the same, okay, on both sides of your square. Then you're going to square this and you're going to get 9. That's what's going to go here, and that's what's going to go here. I am going to do the same thing with my Y. I'll do it on the opposite side of the screen. So I'm going to take my, here, I'll use a different color. I'll use yellow. I'm going to take 12, which is the number in front of my Y, take half of 12, which is 6. I am going to square that, which is 36. Living on the edge, okay? I don't know what I'm doing. Put 36 down here. So I am going to be putting 36 here and 36 here. I know that's hard to see, so I'm going to rewrite it in blue. 36 here and 36 here. So now when I write this, the whole point of this was to get this to be a square, this to be a square, equals some number. On the other side, when I am working that out, I'm going to have a 12 plus 36. I end up with 48 on the other side. Okay, that's my R squared. Don't worry about that. That's the number that goes there. Then when I'm trying to figure out what is going to go in this, it's basically going to be half of your B, half of this number. Half of that number was -3. That's always what's going to go there. So also paying attention to the sign. Okay, whatever sign is in front of your X, that's the sign that has to go here. So this is going to be an X -3. I'm going to do the same idea with my Y. Sorry, I'm just trying to get my spotlight. Same idea with my Y. This half of 12 is 6. That's what we got over here, +6. So I'm going to put a +6 here. Okay, so this is going to be Y plus 6. And that is our equation. Okay, so next problem. So on this one, what is the domain? Okay, so for these logarithms, the thing I'm really concerned with is my vertical asymptote, because where is my vertical asymptote? And my vertical asymptote is going to come from what makes this 0, because we can never take log of 0. Log base 2 of 0 is undefined. We cannot take log of a negative either, but so we don't have any, so if we have a logarithm, we're going to have an asymptote, a vertical asymptote, okay? Let's just say it's a general equation one, and let's just say, so it's on our x-axis, and then what's going to happen is our graph is going to be something like this, okay, where again, our asymptote, x equal whatever our h is, that is going to be the boundary, the furthest that it's going to go, but it's never going to touch. So what makes this 0 is a -7, okay? So that means my domain is going to be open bracket -7 to infinity, open bracket. Okay, next problem. So this one, what is the domain? Okay. So for this one, again, we are looking for this. So if I was looking for our locator point, 11,6 would be our locator point. Just a very, very rough sketch. Okay, this 11,6 would be the start of my square root, and it would go to the right because my x is positive. So that means I'm basically starting at, for my domain, I'm starting at 11, square bracket, because I actually have a point at 11 to infinity. And that's going to be our domain. Okay, next one. Write the equation of a line with a slope passing through the point 1, 2. Okay, so for this, we need to remember the general equation of a line. Okay, I know it's been a while since integrated 1. Y equal mx plus b, but something you got to know. Where m is our slope, and B is our y-intercept, okay? So I'm going to have y is equal to 4x plus b. And then I can put this point in for my x and y to find my b. Do not put that 2 in for your b. That is not your y-intercept. If I was to sketch this, 1, 2 is not on the y-axis. It is not your y-intercept. So don't even think about that. Okay. So I am going to put 2 here. 4 times 1 plus b. 2 is equal to 4 plus b. And I get negative 2 is equal to b. So my equation is y is equal to 4x minus 2. Okay, next problem. So on this one, okay, a ball is thrown 10 meters across a field. The ball reaches the maximum height of 6. Write the equation of the path of the ball if it's thrown at the point 0, 0. Kind of like the problem that we did earlier, okay? So let me just kind of sketch this out. Okay, so we're starting at 0, 0, 0, 0. It is being thrown 10 meters across the field, so 10, 0 is where it's going to end up. The height of the maximum height of this is 6 meters. And remember that the max height is going to be at your vertex, which is going to have to be halfway between 0 and 10, so it's going to be 5. So up here, I'm going to have 5, 6. Okay, I'm going to do that in a different color. Oops. 5, 6, 5, 6. So my equation is going to be y equal a times x minus 5 squared plus 6. I'm going to put 0, 0 in. 0 is equal to a times 0 minus 5 squared plus 6. I'm going to do a couple steps at one time. I'm going to bring the 6 over, so it's a negative 6. And 0 minus 5 quantity squared is a negative 5 squared, which is a 25a. And so my a is negative 6 over 25. So I'm going to come back to my a in my equation. I'm going to get rid of that, and I'm going to write it in, I'll do it in pink. Okay, so this is going to be negative 6 over 25. Here, I'll write it kind of over here. That's not very good. Y equal negative 6 over, I write a 6 would be nice, 6 over 25, x minus 5 squared plus 6, and that's your equation. Okay, next problem. Okay, on this next slide, we are going to solve for x, and this is going to be one where it is an absolute value. It's going to be on a number line. Okay, so we need to give a number line answer and then give an inequality answer. First thing I want to do is I want to get my absolute value isolated. Okay, so I'm going to write it above, just to give myself some more space. So that's going to be 3x minus 4. I'm going to be subtracting 1, and so I get 2x minus 1. So this is going to be the absolute value inequality that I'm going to be solving. So I am going to write my two equations, okay? 3x minus 4 equals 2x minus 1, okay? And 3x minus 4 equals negative 2x plus 1. We're making that opposite. Little note, I know that especially in the honors math analysis classes, and I also usually teach it this way when I teach it to my honors class. Another way to think about it is if we take this 3x minus 4, think of it as a positive and as a negative. So you could do the same problem where you have this equation, okay? You basically take away your absolute values, and instead of the one I just wrote, I'll write in blue that it is okay to have negative 3x plus 4 equal, and you keep the other side the same, okay? That is acceptable. I'm going to be doing the two equations in pink, okay? So then I'm going to be working this out. So I'm going to get x is equal to, by subtracting 2x, adding 4, x is equal to 3. Over here, I'm going to add 2x, so I'm going to get 5x. I'm going to add the 4, so I get 5. I get x is equal to 1. So I have these as my boundary points. I'm going to draw it on a number line. So I have 1 and 3. I know because of my inequality up here, let me do it in green, that this inequality has the equal, so I am going to have solid circles. So I'm going to have a, let me do it in maybe red so we can see it. Solid dot here, solid dot there. I need to decide, am I going to shade in between or am I going to shade out? So I'm going to test a value. And I'm going to test, let's say 2. 2 is in between 1 and 3. So I'm going to put 2 into my inequality. So I'm going to have 3 times 2 minus 4 less than or equal to 2 times 2 minus 1. Let me just do that math down here. Sorry, it's a little messy. So I'm going to get 6 minus 4 in absolute value, which is a 2, less than or equal to 2 times 2, which is 4, 4 minus 1, which is 3. Is 2 less than or equal to 3? That is true. So since that's true, I shade where 2 was, which means I'm going to shade in between. So I'm going to get 1 to 3. The way I'm going to write my answer is, and I'll write this in, I guess I'll just write it in black here. 1 less than or equal to x less than or equal to 3. And here, let me just kind of put a, I don't like these colors. I'll kind of box this in yellow. That is my graph and that is my answer. Okay, next problem. So on this one, we're going to solve. So when I'm working this out, I'm just solving for y. They just have a y in the equation. First thing, I'm going to try to get this isolated. That's my first step. So I'm going to have 4 times y minus 2 squared. I'm going to minus my 5 and get a 20. I'm going to divide by 4, and I get a 5. Now I'm going to square root both sides. Here I get a y minus 2. On this side, when I square root, I get a positive and a negative root 5. And then what I'm going to do is I'm going to add 2. So I'm going to get 2 plus or minus root 5. And that's your answer. Leave it in that form unless you see it as a decimal in a multiple choice situation, but it's most likely going to be in radical form. Okay, next problem. So for this one, write the equation of an absolute value graph with vertex at -4, -2. Okay, so going through this point. Okay, so this is my vertex. So that tells me I'm going to have y equal a absolute value of x plus 4 minus 2. Going through this point, that's going to help me find my a. So I'm going to go 3 is equal to a absolute value -7 plus 4 minus 2. And now I'm going to solve. So add 2 to both sides. And here I'm going to do 2 steps. I'm going to add 2 to both sides, and I'm going to also do -7 plus 4 is -3, but it's in absolute value. So that's going to be a 3a. So my a is 5/3. So my equation, y equal 5/3 absolute value of x plus 4 minus 2. Okay, next problem. On 20. Okay, so on 20, we're solving this absolute value. Again, our first step is to get this, sorry, I went back. This absolute value by itself. That's what I want to do first, okay? That's my first step. So I'm just going to write it above, just to give myself some space. So I'm going to have 3 absolute value of 2x minus 5. I'm going to add the 1, sorry, minus the 1, and I'll get a 48. I am going to divide by 3, so I'm going to have absolute value of 2x minus 5 is equal to 16. Okay, now I am going to write it how the book does it, where you basically write your two equations, you change what's on the other side of the equal. It's either a positive 16 or a negative 16. Now, quick note, you always want to stop at this point and make sure that this is not a negative number. If it was, no solution. So I am going to write this. I'll do it in purple. 2x minus 5 equals 16, and 2x minus 5 equals a negative 16. Again, I know some classes, and I teach it this way too, depending on the class. Instead of making the 16 and the negative 16 opposite, you can make the 2x minus 5 opposite. So you would first start with this same equation that I had over here. Okay, that doesn't change. The second equation would have changed. So you think of it as a positive 2x minus 5 and a negative quantity 2x minus 5. So you would make that opposite and work that out. Okay, so you might be working out the two blue ones. I'm going to work out the two purple ones. Okay, so this is going to be 2x is equal to 21. So x is equal to 21 over 2. Okay, that's going to be an answer. 2x is equal to, I add 5, I get a negative 11. So x is equal to negative 11 over 2. I do not need to check my answers here unless you want to just check your work, because there's no x outside my absolute value. Okay, next problem. Oops, let's see, making sure. Okay, so on this problem, you can use logarithms, but really you don't have to, because an 81 and a 27 are both 3 to a power. So I can do this like we used to do in integrated 1, honestly. 3 to the 4th is 81, and that's being raised to the x plus 4. And 3 to the 3rd is 27. Now, when I do these problems, I understand that power to power I multiply, so I usually write this as my first step. If I know that 81 is 3 to the 4th, it's going to times with that x plus 4, which is the exponent that it's being raised to, that 81 is being raised to. Okay, now at this point, when you have the bases the same, the exponents have to be the same, because 3 to the 5th is not the same as 3 to the 6th or 3 to any other power. Okay, so my 3 to the 3rd is going to be the same as my 3 to the 4x plus 4 in parentheses. So I'm going to take 4x plus 16. I'm just going to do that math. Distribute that is equal to 3. So I get 4x is equal to negative 13. So x is equal to negative 13 over 4. And that's your answer. Okay, next problem. Okay, change in the graphing form. Okay, so just so everyone understands, it should be, now I don't have my a is 1, so I don't have to have an a in front. So it's going to be basically x minus h squared plus k. I'm going to complete the square. So the first thing I'm going to do is I'm going to take that plus 8 to the other side. So I'm going to have y minus 8 is equal to x squared. Here, I'm going to actually write it above. Give myself space. I don't know why I like to start at the bottom of things. Okay, I'm going to move this so it's out of the way right now. Okay, so y minus 8 is equal to x squared minus 10x. Okay, and then I'm going to complete the square. So remember, to complete the square, I want to take my b. I'll do this out. I'll do it out here. Negative 10 divided by 2, that is a negative 5. I then take that negative 5 here. I'm just going to draw a line. I'm going to take that negative 5 and I'm going to square it, and that gives me a 25. So that's what I'm going to be adding to both sides. So I'm going to have y minus 8 plus 25 equals x squared minus 10x plus 25. So this side I'm going to have y plus 17 is equal to, and on the right side, this is going to be x. And remember, whatever half of your negative 10 was, which is a negative 5, that's what goes here. Then my very, very, very last step, and here I'm going to move this now, and I'll write my answer down here. Y is equal to x. I don't need that. Okay. X minus, I don't know why that's showing. Don't need that showing. Okay, I'll just keep it like that. X minus h, wow, got distracted. X minus 5 squared minus 17, and that's your answer. Okay. Okay, so now next problem. We want to find the equation for this, okay? So this is going to be y equal a absolute value, and this point right here is at 1 comma negative 2. So that's going to be an x minus 1 minus 2. Now to find my a, again, you can think of this as a linear situation because absolute values are made up of 2 lines. I'm going up 1, 2, 3 over 1. So my a is going to be 3. So this is y is equal to 3, absolute value of x minus 1 minus 2. You could also have, if you prefer, take a point, and I would take this point. It's has a 0 in it. Might as well use one with a 0. And then put that into this equation over here and work it out. So you would have 1 is equal to a absolute value of 0 minus 1 minus 2. 1 is equal to basically a minus 2. I add my 2, and lo and behold, I got the same 3. Do it either way. Okay, next problem. Okay, so on this one, again, they want us to write an equation. So I am going, whoops, did not want that. Girl. I am going to write an equation, and this equation, my vertex is at negative 1 comma 2. So I am going to have y equal a times x plus 1 squared plus 2. Then, again, to find your stretch, 2 ways to do it. How I do it is I know that from my vertex, if I go out, 1 squared should be 1, 2 squared should be 4, and if I'm not going that height, I know I times by something. So when I go out 1, 1 squared is 1. I went up 1, 2, 3, so my a is 3 because I times by 3. So I'm going to have y equal 3 times x plus 1 squared plus 2. Again, if you don't feel comfortable with that, choose a point, let's say this point at 0 comma 5, put it into this equation for your x and y and solve. So if I do that, I get 5 is equal to a times 0 plus 1 squared plus 2. So I get 5 is equal to 1 squared is 1 times a plus 2. And again, I got a is 3. Both work. Showing both because sometimes one way works for people and maybe the other way is a little confusing. Choose the way that works for you. Okay, next problem. Okay, so on the next one, again, an equation. So this is going to be what, keep forgetting my pen. Y is equal to a, and we want to look at our inflection point. Here's our inflection point, okay, or our locator point. And this is 0 comma negative 3. So I'm going to have x plus 0 cubed minus 3. I really don't need that x plus 0 cubed, so let me clean that up. and it's an x cubed minus 3 because the graph's just being moved down 3. Okay, nothing's happening to my x. Now to find your a, again, I'm going to do it 2 ways. The way I think about it is, again, I'm just doing 1 cube now because this is a cube, so I'm doing 1 cube. So if I go out 1 cube should be 1. I should be up here going up 1. I did not. I went out 1 cubed and I went down 1. That means my a is a -1. I times by a -1. So my equation is going to be, let me just write it in a different color. Y, let me grab a color. Y is equal to negative x cubed minus 3. Normally a cubic graph should be going this direction like this, okay? That's what a positive one looks like. The other one is a -1. Now, again, you can always use a point if you prefer. Take a point. So, for example, this point is positive 1, 1, 2, 3, 4, 1, -4. You can put that into this equation here and work it out, okay? Giving us -4 is equal to a times 1 plus, well, I don't even know why I'm, put it into the one below it, okay? Don't need to put it into the one. So here, let me clear that. Let's put it into this one here, this one here that I cleaned up. That would be more logical, right? Okay, so I am going to get -4 equals a times 0. No, I'm using, sorry, forgot what point I'm using. I'm using 1, -4. So 1 cubed minus 3. So I get -4 is equal to a minus 3. I add my 3 and I get -1 is equal to a. Again, I got the same stretch. Okay, clear. Next problem. So on the next problem, we're solving this system of equations. We actually have a parabola and a line, and we want to know where they intersect. So you need to give me an x and a y. If you have an x and y in your equation, you need to give me an x and y in your answer. So you're going to be giving me points. Okay, now notice this one here is a y, and this one is a y. So you, since they're both y equal, back in integrated 1, you guys learn to do equal values. So this is going to be 3 times x minus 1 squared minus 2 is equal to 5x plus 5. I am going to clean up this side right here, okay? So this is going to be 3 times, and x minus 1 squared. It is an x minus 1 times an x minus 1 if you want to do a box, okay? But we need to start knowing the formula. If it is an a minus b squared, for example, the formula is a squared, where you square the first term, you multiply your a and b together, and you always get 2 of them when it's a square, so you get a -2ab plus b squared. If you know this formula, life is much better for you. Everything's faster in math. But if you need to do the box, do the box. It is not x squared minus 1 or x squared plus 1, though. So this is going to be x squared minus 2x plus 1. Again, here, let me just get my pointer for a sec. I squared this first term, x squared. I multiplied these together, which is a -1x, and then I doubled it, which is a -2x, because I would have gotten it in my area model in 2 spots. And then I square my -1, which is a +1, okay? Okay. So let me finish this. I have my -3 equals 5x plus 5, okay? So this is going to become a 3x squared minus 6x plus 3 minus 3 is equal to 5x plus 5. Okay, I'm going to just kind of clean up what I have over here real quick. Okay. So when I do that, I end up, I'm going to get everything on one side, 0 on the other side. So I'm going to have a 3x squared. My x's, I'm going to have a -11x. And then I had my, oh, whoops, mistake. Too bad you guys can't say, hey, this was not a 3, it was a, trying to emphasize and circle it, but dramatics have stopped since I didn't grab my pen. It is a -2. This should be a -2. Apologize, sorry. Doing a lot of videos. I'm obviously cannot do math anymore today. Okay, so this is right. Okay, try it one more time. -2 here, so this is a -2 here. Okay, try it one more time. Okay, so for my numbers, I am going to get a 1 on the left-hand side when I do my 3 minus 2. Okay, I'm doing a point since I'm probably confusing everyone at this point. This is a 1, okay? And then I have my 5, so I'm going to subtract 5. So I'm basically doing 1 minus 5. So that should be a -4. -4 equals 0. And now I'm going to solve this, okay? I'm going to solve this. Oops, switch screens. Like all of a sudden, wait, where did the problem go? Okay, there we go. That makes more sense. Okay, so when I'm working this out, we eventually want to start being able to factor these without having to do an area model, but I'll do an area model, okay, because I want us to get it right to a diamond. In my smallly written area model, let me make this a little bigger so I can actually write inside of it with my finger. This area model, that's a little better. Okay, I'm going to have my 3x squared and my -4. That multiplies to a -12x squared and adds to my -11x, okay, from my equation. That is going to be, I'm going to do it in yellow right now, that is going to be a -12x and a +x, okay? So I am going to have a -12x and a +x. And then doing the math, I'll have a 3x and an x plus 1 minus 4. So my factors are 3x plus 1. I'm not going to write black there because I'm not going to be able to see it when I get to the black. Okay, so I will do it in red. So I'm going to have a 3x plus 1 times an x minus 4 equals 0. I get x is equal to a -1/3 and x is equal to 4. So I am going to have a -1/3 comma something and a 4 comma something. Let's start with the 4. That's a little easier math. I would recommend, because you're going to put this into either equation, this equation will be the easiest. So I'm going to put a 4 right here. 5 times 4 is 20. 20 plus 5 is 25. So this is going to be a 25. Then I am going to put my -1/3 in here, okay? And so when I do that, I'm going to get 5 times -1/3, which is a -5/3, okay? And if I do, I'm doing this on my calculator, -5/3, okay, plus 5, I end up with a 10/3, okay? I end up with a 10/3, a positive 10/3. And those are my 2 points of intersection. Okay, next one. Okay, so here we have a quadratic inequality, okay? So I am going to, and I'm going to start higher than lower this time. I am going to bring over the 8, so it's 3x squared minus 10x minus 8 less than 0. My inequality will not change unless I multiply or divide by a negative. So you can keep your inequality and if you want, and just understand that the only time it will ever change is if you physically multiply both sides by a negative, or divide both sides by a negative. Okay, so now I'm going to do a box area model and work this out. So I am going to have a 3x squared and a -8, which is a -24x squared, and it adds to a -10x. that you want to be careful, because 6 and 4 do give me 24 and 10, but it's a negative 24. So they actually have to subtract. They're going to be different signs. So it's going to be a negative 12x and a 2x. Negative 12x and a 2x. So when I'm working this out, let's see, I'll do pink. My 3x is going to be here and my x here, plus 2 minus 4. So I get a 3x plus 2 times an x minus 4 less than 0. I want to know, where are they 0? Where are they 0? They're going to be 0 at negative 2/3 and at 4. Those are going to be the boundary points on my number line. Okay, so here's my number line. So I have a negative 2/3 and a 4. And if I look at my original inequality here, okay, where I got my everything on one side, 0 on the other, this is a less than, okay? So these are going to be open circles. So let me get my open circles. Okay, it's going to be, let me get a color. Open circle here, open circle here. Now you can test a point like 0 and put 0 in and work it out, and I'll do that here in a second. Another way to kind of think about it is, I think about it as, this is a parabola. The two pink open circles are where it is 0. That is like those are my x-intercepts. So I'm going to grab a green color for a second, and this is an open up parabola. So I kind of think about it like this. It is an open up parabola. Okay. And now let me get my spotlight. So I want to know, where is this parabola less than 0? Where is this parabola below the x-axis? So here and here, these two pink circles, this is where it is on the x-axis. In between here, it is below the x-axis. Outside of 4, it is above. Outside of negative 2/3, it is above. And again, I want it where it is beneath, less than, so right here. So I am going to be shading in between, and that's my graph, okay? That's kind of how I think about it. But another way to do it is to test a point. So let's say I test a point. I'll do this in purple, okay? And so a point to test something in between negative 2/3 and 4. So let's say I try 0. Okay, 0 is not perfectly, exactly halfway. I don't care. It's in between them. Okay, I'm just putting the 0 there to know that's where my 0 is. So I can come to my problem, and if you want, you can come to your original one here. Okay, 3 times 0 squared minus 10 times 0 less than 8. So this is going to be 0 minus 0 less than 8. So I get 0 less than 8. That is true. And so I would shade where it's true, and it's true in between. Okay, both ways gave me the same answer, whatever way works for you. Now, my last step, I'm not done. I need to actually write out my answer. So when it's in between, start with your smallest number, negative 2/3, and then you're going to use less than or equal to, if it was solid circles. And your inequalities need to go the same direction. Less than x, less than 4, and that's your answer. Okay. Next problem. Okay, on this one, okay, I'm going to draw in here. Hold on, let me get a color. I'm going to draw in my asymptote. Okay, so it looks like my asymptote is here. Okay, I know it looks like it's touching, but I think we zoomed in, it would not be touching. Like, at least that's what I'm going on. This is going to be x equals 3. Okay, and I don't really know that much about this graph in terms of its base. Here, I'm just going to do it as a common log. Okay, so I'm going to say it's going to be y equal log, and because of that asymptote, it is going to be an x minus 3. And then this point, okay, let me get my spotlight. This point right here, that is 1 away from my vertical asymptote, okay? Normally, if I haven't moved my graph down, I would be doing it here on the x-axis. So I would, for example, go, oh, log of 0 is, well, log of 0 is undefined. That would be here. Log of 1 is 0. I'd have a point here. Log of 10 is 1. I'd have a point up 1. So this height, this locator point tells you how far down your graph has dropped. So it's dropped down 2. So then this is going to be a -2, and that's your equation. Again, I'm just assuming it's a common log base 10. Okay, next problem. So on this one, you need to get, if you have more than one log on one side, you need to clean it up and get them to be a single logarithm. This minus here means that this is log of a quotient. I will be taking this 2x plus 6, dividing it by the x plus 3. So I am going to have log of x minus 1 is equal to log of 2x plus 6 over x plus 3. Now, when you have a log equal a log, okay, we have a log equal a log. We can take what the log is equal to, and I mean, what you're taking the log of, and set them equal to each other, okay? So I am going to be basically taking this x minus 1 and this 2x plus 6 over x plus 3 and setting them equal. So x minus 1 is equal to 2x plus 6. Let me give myself some more space because it's going to end up being quadratic. I'll try to give myself some space. Okay. So x minus 1 is equal to 2x plus 6 over x plus 3. So I am going to multiply both sides by x plus 3. So I'm going to have an x minus 1 times x plus 3 on this side equals 2x plus 6. I am multiplying out x plus minus 1, x plus 3. That will be an x squared sorry. Well, let me get this again. Plus 2x minus 3 is equal to 2x plus 6. So when I do this now, and I get everything on one side 0 on the other side, I changed it to a different picture. Hold on. Sorry. There we go. You guys got to keep me honest. Okay. So here, when I solve this, I'm going to get x squared. I'm going to minus my 2x, so that's gone. And I'm going to minus my 6, so I get a -9. This is actually going to be an x plus 3, x minus 3 when you factor it. So I get x is equal to -3 and x is equal to 3. When you have logs, you need to make sure that you never take log of a 0 or a negative, okay? So when I put this in, if I put it in here, it's going to give me a negative, that -3. Here it's going to give me a 0, still not good. Here, still not good. So this one here is not going to be an answer, okay? Not going to be an answer. Then if I put in a 3 minus 1, that's positive. This is going to make this positive, positive. So this, hold on, let me grab it and stop clicking. Sorry, wow. And this is going to be my answer, x equal 3. The other one is extraneous. Okay. Next problem. Okay, on 30, what is the equation of a circle centered at 3, -1, passing through 5, -4? Okay, so for this, my circle, since my center is this, that is going to give me x minus 3 squared plus y plus 1 squared is equal to r squared. I'm trying to figure out my r squared. So now I'm going to be putting this 5, -4 in for my x's and y's. So I'm going to get 5 minus 3 squared plus negative 4 plus 1 squared equals r squared, and I'm going to do that math. So I get a 2 squared, I get a negative 3 squared equals r squared. This is a 4 plus a 9 equal r squared, so I get 13. So my equation, let me write it in pink here, is going to be x minus 3 squared plus y plus 1 squared is equal to 13. That's your equation. Okay, next problem. Okay, so we're shifting the graph up 5 and left 6. What might be helpful is kind of think about where the original graph was. So the original graph was at 4 comma negative 8. And so this up 5 is going to be affecting this. So I'm really going to be adding 5 onto my x, okay? And this left 6 is going to be affecting the 4. So what I'm going to be doing is I'm going to be subtracting 6. And so my new vertex for this is going to be negative 2, negative 3. Your stretch is not changing. We're shifting. It's not changing. Same shape. Okay, so it's going to be y is equal to 2. And because of the minus 2, this is going to be x plus 2 squared. And because of the minus 3, this is going to be minus 3. And that's your equation. Okay. Another way to kind of think about it is, again, this 5. I'm adding 5 on to this number here. Okay, this negative 8. And then I'm left 6. I was at a positive 4. I would do it the way I showed. That way there's no confusion in terms of signs, because this, when it's in the x, it's going to be opposite. So I would just find your vertex, adjust the vertex from, if it's up, it's positive, you're adding. If it's down, it's negative, you're subtracting to the y's. If it's left or right, left is negative, right is positive, that affects your x's. Okay. Next problem. On 32. Okay, we're going to find the inverse. So for this, I am going to have x equal 1/3 times the square root of 3x plus 2. Sorry, I forgot to put my y in. I'm switching my x and y. Switching my x and y. So I need to switch my y. Okay, so I switch my x and y. I am going to now get this to be in y form. So I'm going to multiply by 3. I am going to square both sides. So when I do that, I'm going to get a 9x squared equals 3y plus 2. I am going to minus 2. I'm going to divide by 3. So when I divide the 9 by 3, I get a 3x squared. When I divide the 2 by 3, I get a 2/3 is equal to y. This is going to be my equation. And just a quick little note, I just put in Desmos my original 1/3 square root of 3x plus 2, which is the red one. And then I put in the blue one, which is my inverse, okay? But I do not have that whole entire parabola, because what happened was I only had, and here, let me see if I can get my annotations over here, sorry. I only have, I'm gonna do this in pink, okay? And I'm doing this not on my touch screen here right now. So I only have the positive square root, okay? I do not have, if I do this in a different color, I do not have the negative square root. So again, let me kind of get my mouse back. That is my positive. If I copy this, I'm going to paste it down here and just stick a negative in front. And I'm going to make this one be dashed. Okay, so that dash one, I do not have that negative square root. So I do not have a whole parabola when I do the inverse. I only have half of a parabola. I have my y's are greater than 0. I don't have my y's less than 0. Okay, so what that means is I do have a restriction here. Let me get rid of this now. I do have a restriction here. Since I only have my y's greater than 0, if you're thinking of it as a sideways parabola, I only have the positive root, not the negative root. That means that I have a restriction here. If my y's were only positives, now my x's are only positives. And so if I come here and put in x is greater than 0 in squiggly brackets, you see it's switched my parabola to only being the half. And you see I put in y equal x, you can see that there is a line of symmetry. Okay. Okay, let me. So again, what that meant is since this graph right here, the square root graph, okay, this was really in terms of its locator point at -2/3, comma 0. The comma 0 is what I care about. I only have the positive, not the negative. So my y is greater than or equal to 0 here, which means for my inverse, my x has to be greater than or equal to 0 because I don't have that whole parabola. I just have from that vertex to the positive direction of my x-axis. Okay. Next problem. So we are solving this, and so it's isolated. So I am going to basically work out x minus 3 equal 5 and x minus 3 equal -5. Again, you might keep that as is and make the inside opposite as your second equation. So again, some of us might keep the equation where it's x minus 3 equal 5, which is the same in both ways. Okay, what's the changes? I'm making my 5 positive and negative. Some classes are making the x minus 3 positive and negative. So that means that you would be working out -x plus 3 equals a positive 5. Okay, either do it all in blue or all in red. Okay, I'm going to do it in red. So I get x is equal to 8. I get x is equal to 2, -2. And so that is going to give me on my number line a -2 and an 8. And looking at this, this is strictly less than. So that means I'm going to have an open circle here, open circle here. You can test a point. Okay, you can test a point. So let's say I do 0 because 0 is in between these. And I go 0 minus 3 less than 5. 0 minus 3 is a -3. Absolute value of that is 3. 3 less than 5 is true. So I would shade in between here. Okay. Another way to think about this, this is kind of how I think about it. Just like I did with a parabola, this is a square, this is an absolute value graph. The 2 points I just plotted, my -2 and 8 would be where it touches the x-axis. I want where my absolute value, well, in this case, not the x-axis, sorry, a height of 5 because the 5 is here. So this is where I'd be at a height of 5. So if on my graph, if I drew in a line at y equal 5, I would touch this graph at -2, 5 and 8, 5. That's where I am. So I'm thinking of this as a height of 5, okay? So that I'm at y, here, let me do it on the black. I'm out at y equal a height of 5, for example. And so what I want is where is this absolute value lower than 5, less than 5. Here is where it is 5. This is where it's lower than 5, on the outside where it's higher than 5. That's another way of thinking about it, okay? You can also think about it the following way, where when you have an absolute value with a number on the other side, you're kind of thinking about where you are going to be less than that distance away or more than that distance away. Less than that distance away would be in between, more than would be outside, okay? Probably the safest bet is to put in a 0, but just kind of giving you some other ways to think about it. Now, your final answer is going to be -2 less than x less than 8. That's going to be your graph and your answer. Okay, next problem. Okay, how many solutions does a triangle ABC have if B is 25, A is 33, and B is 100? So I am going to draw a triangle. Let's say this is A, this is B, this is C, this is 100 degrees, this is 25, A is 33, and we want to know how many solutions this has. So looking at this, I do have angle, side, side, or side, side, angle, which is when you have that ambiguous case. Now, so I could have more than one. So I am going to be taking the 100 and the side opposite it, and I'll be using law of sines. So sine of 100 over 25 equals, and I'm going to be taking the 33 and A. I don't know what that is, so I'll do sine of A over 33, and I'm going to cross multiply and solve this. So I'm going to get, I'm going to do it this way. I'm going to cross multiply, but when I do that, I'm going to be dividing by my 25. Okay, so I'm going to take my 33 sine of 100 divided by 25. Now I want the actual angle, so I am going to have to do the inverse. So A is going to equal sine inverse of this 33 sine 100 over 25. That's a 100. So when I do this on my calculator, make sure it's in degrees. Okay, make sure it's in degrees. Let me just kind of show. Okay, so on this, I was going to show you, but as I changed my screen, I lost all my math work. So I'm just going to put it in my calculator. I like to use alpha y equal, which gives you fractions on the graphing calculator. So I'm going to do sine inverse, making sure my calculator's in degrees. And I'm going to do alpha y equal on my graphing calculator to get it as a fraction. And then I just type in 33 sine 100 over 25. And I ended up with error. Gave me error on my calculator, equals error. So this, I'll do my R in a different color so you can see it. This, well, that doesn't even matter. Okay. So this gave me error. So that means that there are no triangles, 0 triangles, okay? Now, if I was just to work out the thing I put in my sine, and that was my sine inverse, or if I do 33 sine of 100 over 25, that gave me this part right here, just so you guys understand why this is happening. This part right here gave me a 1.30 if I round. And sine will never, ever, ever be more than 1 or less than -1. It's always in between 1 and -1. We're going to learn that second semester when we start graphing these things. That is why there's an error. There's no value, no angle of sine that will give us a 1.30. Cosine, sine, both of them are in between 1 and -1. Tangent, different. That's different. Okay. So I am going to go to the next problem. Okay. So, whoops. The next problem, write the equation of an exponential that passes through the point 0, 6. Okay, 0, 6. So this tells me my A is 6. okay? Because I'm assuming, they didn't say, but I'm assuming that it should be y is equal to a times b to the power x minus, sorry, just x minus h, okay? No left or right movement here, okay? So my a is my, when it's not being moved left or right, is always my, my a, okay? My y-intercept is always my a if it's not being moved left or right. And then I have that minus 2, okay, that I'm dealing with. And honestly on this, I do not think we even have our minus h. It did not mention anything about an asymptote. So I'm going to be using this formula. Okay, sorry, I'm changing my mind. Okay, so on this, I'm going to be using this general formula, trying to find my a. And then my b, what am I multiplying by? So my a is 6 because that is my y-intercept. So I know it's going to be y equals 6 times b to the power x. Then I can put this point in 1 comma 2, okay, and work it out and get 2 is equal to 6 times b to the 1, which means 2 is equal to 6b. And so basically when I divide by 6, I get 1/3 is my b. So my equation is going to be y equals 6 times 1/3 to the power x. Another way to kind of think about this is if you're kind of looking at the graph and you're starting up here at a height of 6, and then you're now at the next point down at 2, what did you do? You divided by 3 or multiplied by 1/3, and that's your a. That's another way to think about it. Okay, next problem. So on this one, what is the domain of this? So really we care about where our asymptote is going to be. And for this graph, we're looking at this x minus 3. So x equal 3 is where my asymptote is going to be. So this is going to be, for my domain, open bracket 3, because that's where my asymptote is, to infinity. Okay, a sketch of this. Okay, again, rough sketch. Let's say that this is x equal 3. My graph is going to be moved up 5, so maybe it's up here. And there you go. Okay, next problem. So this one, we want the domain. So if the domain of my original, so let me just jot this down here. So my original f of x, okay, my domain was 1 comma, well, 1 to open bracket 1 to 8 open bracket. My range was close bracket -2 to 4 open bracket. Now, what we have happened with our x and y, remember we switch our x and y. So for my inverse, what happens is my domain now becomes my range. So this is going to be a 1 comma 8, and my range now become, and sorry, this should have stayed a close bracket, sorry. I mean open bracket. Open bracket. Oops, got a line by mistake. Open bracket. Okay, and my range is now going to become my domain. So this is going to be -2 close bracket to 4 open bracket. So again, they wanted us to find the domain of the inverse. So the domain of the inverse is the range of the original, -2 to 4, -2 close bracket, 4 open bracket. Okay, next problem. We're factoring this. Okay, so the very first thing I'm going to do is I'm going to see if I can factor something out of everything. So number wise, I have a 12, 22, and -20. I can take out a 2 from that. Also looking at this, I have an x here, an x here, an x here, so I can factor out an x. And then I'm going to be left with 6y squared plus 11y minus 10. And then I'm going to do a box to diamond to see if I can factor that. I'm going to have a 6y squared and a negative 10, which gives me a negative 60y squared and an 11y. Now, first off, understand that since this is a negative, one of these is going to be positive, one of these is going to be negative, so we really want a difference of 11. This is going to be a 15 and a 4, but if you don't know that, you couldn't think of that. List in number order, systematic way. 1 and 60, 2 and 30. What multiplies to 60? 3 and 10. Okay, none of those have a difference of 11. 4, maybe I don't know if 4 goes into 60. See if 4 does, and it does. It goes in 15 times, and 5, 12, and well, sorry, this is not 310. 320. Didn't work anyways, but let's write the right number. That should have been a 20. I don't know, I might have said 20. Definitely didn't write 20. Okay, and 6, 10, and so on. But looking at these, this one has a difference of an 11. So this is going to be a 15y and a negative 4y. 15y, negative 4y. And then when I'm focused on my 6y squared, this could be a 6 and a 1 or a 2 and a 3. Seeing a 15 and a 4, it definitely is not a 6 and a 1. Okay, so it is going to be a 3 down here, a 2 here, minus 2 plus 5. So now my final answer, 2x times 3y minus 2 and 2y plus 5. That is my final answer. Okay, next one. Okay, again, what is the domain? So if you are thinking about this as, whoops, skipped. If you are thinking about this as a graph, I don't know why I keep doing that, sorry. Okay, try it one more time. Let me get my actual pen. Okay, so if you're thinking about this as a graph, this has a locator point at -2 comma -4, and then it's going this direction. Because it's a positive x, it's going to go to the right. If it had a negative x underneath the square root, it would have gone to the left. So the domain of this is going to be square bracket -2 to infinity. Okay, next problem. On this one, we're going to rewrite this in logarithmic form. So this base is always our base. So this is going to be log base 3. And whatever you're taking the log of, what your log equals is always your exponent. So understand that this is always what the log equals. Log is meant to find the exponent. So this is going to be log of 27, log base 3 of 27 is equal to my exponent, which is x plus 2. And they just wanted it in logarithmic form. Okay, so log base 3 of 27 equals x plus 2. I can minus the 2 and get log base 3 of 27 equal minus 2 equals x if I was then going to try to solve. Okay, next problem. Okay, so we want f of g of x, composition of function. So you always want to start with what is in the inside, g of x. This is g of x. So I am going to be trying to find f of this. That's what I'm going to put in here. Okay, so I'm going to be finding f of 1 over 3x minus 5. So I am going to be putting that into the x in this equation. Okay, so I am going to be finding 2 times 1 over 3x minus 5 minus 3. When I'm multiplying that, the 2 is going to multiply on top, so I get 2 over, let me get my pen again, sorry, press something, 3x minus 5 minus 3. That is my answer. Just leave it like that. Okay, don't need to try to get it into a single fraction. Okay, next problem. Okay, solving for x. Cannot get both bases to be the same. 3 does go into 6, but 6 is not 3 to any nice power. So I am going to log both sides. I'm going to take the log of this side, and I'm going to take the log of 6, common log, base 10. Now, when I take the log of 3 to the power x, the x is going to come in front. So I'm going to get x log 3 is equal to log 6. I then am going to divide both sides by log 3. So log 6 over log 3. I'm going to put that into my calculator. And log 6 divided by log 3. Make sure you close your parentheses unless you're entering it in the fraction form. 1.63 is my answer. And that makes sense because 3 to the first is 3 and 3 to the second is 9. It has to be somewhere in between 1 and 2. Okay, next problem. Okay, so for this one, we're going to be finding the inverse. Okay, so to find the inverse, remember we switch our x and y. So this is going to be x is equal to 3 to the y minus 4 minus 10. Now, exponentials become logs and logs become exponentials, but you want to get your base to a power, that 3 to a power by itself. So I need to get rid of that minus 10. I add 10 to both sides. Now I'm going to use logarithms. I'm going to write it in logarithmic form. Okay, so to write it in logarithmic form, this is going to be log base 3 of x plus 10 equals our power y minus 4. And then my very, very last step is to add the 4. So log base 3 of x plus 10 plus 4 equals y. Okay. And 44, we're going to write it in logarithmic form. So any of these with a minus are going to be in the denominator, because really it's like a negative exponent in front if I moved it in. Any of these with a plus are going to be on top in the numerator. The ones with the pluses would be multiplying on the top together. The ones with the negative would be multiplying on the bottom together. So for this problem, the answer is going to be log of, let me get my fraction. My m is going to go on bottom because it's a minus. The plus means the k is going to be on top, and so is the p. And that's your answer. Okay. Next one. Okay, largest angle in the triangle. So when we're doing this, you need to remember from integrated 2, I'm not drawing this to scale by any means. Okay, so don't say, well, it looks like it's bigger or smaller. So across from A is little a, 5. Across from angle B is little b, 8. Across from C is angle C is the little c, which is 11. So always the largest side is across from the largest angle. So since this 11 is the largest side, the C has to be the largest angle. So I'm going to be trying to find C. Now, in this case, when I do not have any pairs that match, meaning opposites C and 11, I don't know. Both of them, I know one of them. My 5 and my A, again, I don't know both of those. My B and my 8, I don't know both of those. So when I don't have those opposite pairs, you're not going to do law of sines. You're going to have to use law of cosines. And again, I'm trying to find C. So I'm going to start cosine of C is equal to A squared plus B squared minus C squared all over 2AB. So I'm going to get cosine of C is equal to, and here really the one you're concerned about is the C, the 11. That's going to be the minus, okay? So that's going to be 5 squared plus 8 squared. And again, my minus is going to be the 11 squared because it's across from my C. All over 2 times my A, which is the 5 and the 8. I can put this in my calculator. I'm going to do this one big step. So I'm going to do C is equal to cosine inverse of that whole entire thing. Okay, that whole entire thing. And here, I'm just going to kind of clean it up slightly. So that's a 25 plus 64 minus 121 over 80. But again, you don't even have to do all that. You can just do cosine inverse of the rest of that using, making sure calculators in degrees. So I just typed cosine inverse, and I'm going to do my alpha y equal on my calculator, get it as a fraction. And so I have 5 squared, which is 25, plus 8 squared, which is 64, minus 11 squared, which is 121, over 2 times 5 times 8, which is 80. And I ended up with my C being 113 point, if I round it, 58 degrees. And that's my answer. Okay, next problem. Okay, odd or even. Okay, so basically when you're doing these in terms of the algebra, if you have f of x as your original, okay, and you put in a negative and you got out the same as f of x, that would lead to it being even, okay? If you put in a negative x and you did not end up with f of x, but you ended up with the opposite of f of x, that would be odd. If neither of those happen, it's going to be, it's going to end up being neither. So if I do that here, 4 times negative x minus 1, I get a negative 4x minus 1. Now that's not the same, and it's also not opposite, because the opposite would have been a negative 4x plus 1. So this is neither, okay? Do the same thing here, put in a negative x cubed plus 2 times a negative x. I end up with a negative x cubed minus 2x. Now these are opposites, so this is going to be odd. For the next one, I have no x to plug into. So my positive x, for all positive x's, I'm going to get 2 because this is a line, okay? This is a line. The line is y equal 2. Okay, so let's say that's y equal 2. It doesn't matter if I'm dealing with a positive x, I'm going to get 2, or a negative x, I'm going to get 2. I always get 2. So this one is going to be even. Okay, my positive and negative x are going to be the same. On my last one, negative x squared minus 3, I'm going to get a positive x squared minus 3, which is exactly the same. So this is going to be even. Okay. And that's the last one.